All right, let's talk about the factory pattern. So imagine an application is written specifically for the Microsoft Windows platform. Okay, so we might have this client GUI that asks to create windows and scroll bars and a whole bunch of other widgets. In other words, a client uses a window and it uses a scroll bar, and all of these GUI components are specific to the Windows platform. Now we know Windows applications have their own look and feel. So if you're a Windows person, you know that all the Windows controls are in the top right of the window. So you can minimize and kill an application all by going to the top right. But if you're a Mac, well, the controls to control a window are in the top left. So we have these little bubbles here. They each do the same thing, basically, but they each look a little bit different from each other. Okay, so now imagine that your application that you wrote for the Windows platform is wildly successful, and you're asked to port it to a Mac, a Linux, and all the other operating systems. Ideally, what you do is abstract the platform-specific stuff out of the code. In other words, this picture here, these classes were specifically from the Windows library. Well, now that we're porting to all these different platforms, we want to kind of make this generic. We want to have a generic window and a generic scroll bar, and we want to fill in the details later. Okay, so the factory pattern will allow your app to ask for a family of classes, and you don't have to worry about which family it's working with. Okay. So the intent here is to provide an interface for creating families of related objects without specifying their concrete classes. So the motivation here, instantiating concrete objects in an application makes it hard to change those objects later. We can solve this by creating a factory interface that will create objects by family type. And then for each family, a subclass is created that will make the correct objects. The client is unaware which family they're using. Okay, so what our goal is to do is to make a family of classes of widgets for the Windows platform, but then have another family of widgets for the Mac platform. And our goal is to make the client not really know or care which family it's working with, since they're basically the same. They just they come from these different, let's say, libraries. Okay, so let's look at the structure of this pattern. This picture is a little bit complicated, but I think it'll make more sense once we map it to our particular application. So up here we have the client class, and the client has a reference to this abstract A, so think a window, and it has a reference to this other product, abstract B. Think of that being kind of an abstract scroll bar. So we have an abstract window and an abstract scroll bar, and then we have different products. Right? So this is a Windows window, and this is a Windows scroll bar, whereas over here we have a Mac window and a Mac scroll bar. So obviously they inherit from the same interface. All windows inherit from this abstract window interface, and all scroll bars will abstract from the scroll bar interface. Now the factory is the class that has these methods to create different products. So create a window, create a scroll bar. And then we have concrete factories. So the Microsoft Windows factory will go and create a Microsoft Windows window and a Microsoft Windows scroll bar, and the Mac factory will create a Mac window and a Mac scroll bar. Okay, so it's probably easier just to look at the actual mapping of this pattern. So again, we have our client over here, and clients just know that they have references to windows and scroll bars and any other widgets that are needed. Okay, so in the abstract window interface, of course, we can create a Microsoft Windows window or a Mac window. And a scroll bar, we can have a Windows scroll bar or a Mac scroll bar. Okay, the widget factory, This is actually an interface that says, I forgot to write that in there, but that is definitely an interface where there are methods to create a window and create a scroll bar. And then what we do is we have these concrete factories. So again, the Windows factory implements this interface and it fills in the details to create a window and create a scroll bar. Okay, so when those methods are called on a Windows factory, it will go and create and return a Windows window. And it'll go and create a Windows scroll bar. Whereas the Mac factory, when we call create window, that'll go and create a Mac window, and similarly this will create a Mac scroll bar. Okay, so I did forget to mark that as an interface. Let me do that now. And I also forgot one other thing. So this is definitely an interface. And the other really important thing I forgot is that a client gets access to a factory. It doesn't really know what type of factory it's using, and it doesn't need to know, but it's going to ask this factory to create the components for it, create the window and create the scroll bar. Okay, so maybe we can kind of look at some code and see how this would work. Okay. So imagine we had this driver here. Okay, and this is again our Mac and Windows program here. So we have this reference to a widget factory, which remember is an interface. It just knows it has these methods available to it. And basically we're going to check to see, well, are we on a Mac? Okay, so one way to check what type of system you have is you can use the system object and find out the operating system name. Okay, and if we are running on a Mac, what we'll do is we'll create a Mac factory. So this generic widget factory will point to a Mac factory. Otherwise, it's not a Mac. Let's assume the only other platform is Windows, and we'll set the factory object equal to a Windows factory. Okay. So now when we go and create our GUI elements, we don't really know what kind of scroll bar and window, either Mac or Windows, this factory will give us, and we don't really need to know. So what we do is we have references to the generic scroll bar and window. So remember, we have a generic scroll bar and window here. They basically do the same things. But then we ask the factory to go and create either the scroll bar or the window. Okay, now the client doesn't need to know what platform we're on, other than this one check when the program starts to choose a factory. We now just rely on the factory to create all of our widgets. Okay, and this is a really nice way to simplify your client so it doesn't need to know all those things. Okay, so the participants, we have the abstract factory that declares an interface for creating abstract product objects. Concrete factory implements the missing factory methods to create the actual concrete product objects. We have the abstract product, that's an interface for a product, in this case a window or a scroll bar. We have our concrete products. This implements the abstract interface and will be built by a concrete factory. And then of course the client only knows about the abstract factory and the abstract product. It doesn't know anything about the concrete factories or products. Now the factory pattern works well with some other patterns. So the proxy, the decorator, the strategy. These are all patterns where one object gets plugged in for another. So let's take a look at the proxy again. Let's go and just kind of remind yourself about the proxy. We have this client which has a reference to a generic server that we can do something. And we either pass in a concrete server or a remote server proxy. So if the server is going to be run locally, we can just use a concrete server. if the server is going to be on a different machine, we have a remote server proxy. Okay. The client will either work directly with the Concrete server or the remote proxy. So if it's working with the Concrete server, remember we had this relatively simple sequence diagram. The client asks the Concrete server to do something, and it does it and maybe returns some data. Okay, that's working with a Concrete server. But it might also work with a more complicated remote server proxy, in which case we do have a Concrete server, but it's on a different machine. And we have the client proxy is kind of the stand-in for the client that talks to it on the machine. And then on this other machine, the client talks to a remote server proxy. And when the client asks the remote server proxy to do something, that's when the remote server proxy sets up the socket and sends the data, sends a particular message across the socket. Client proxy then parses it, figures out what method to call on the Concrete server, calls it, gets a value, and maybe the client proxy will send something back to the remote server proxy, which will then send that back to the client. Okay, so that's a little more complicated, but we learned about that in the proxy pattern. So of course we can shield the client from knowing which type of server it's dealing with by using a factory. Okay. So ideally what we'd like to do is not have the client know whether it's talking to a Concrete server or a remote server proxy. The client just knows it has access to a server, and it's going to ask the server to do something, and maybe that'll be create a socket and ask some other machine to do something, or maybe it's a local server and it'll just do it and return something back. That's our goal, is to kind of completely hide that from the client. Okay, so let's look at some code about how we might do that. Okay, so it would all start with this interface for a server factory. So this is a method, create server, that will return a server. Okay, and we have to remember, there are different types of servers. We have, the Concrete server and the remote server proxy. So our factory method is just going to return a generic server. Okay. Then we have these different Concrete factories. So we'll first start with the remote server factory. Implements server factory, implements this interface right up here, which means it must provide a method called create server that returns a server. And what does this factory do? Well, maybe it finds the IP address and port number of the client. Maybe it does some other stuff. But eventually it's going to create a new remote server proxy and maybe pass in the IP and port number. It's going to create this object and then return it. Right? And that's okay because a remote server proxy is a server. It implements that interface. So this is perfectly fine. Then we have another factory, just a local server factory, which doesn't need to create any sockets or anything. It's just going to create a Concrete server and return that when somebody calls create server. Okay, now the client. Again, the client just knows about this generic server. It might be a real server or a Concrete server, or it might be a proxy. When we create a client, we always pass in a factory. And again, this is the generic server factory. This could either be a remote server factory or a local server factory. Okay, we don't really know. And in the client constructor, what we do is we ask the factory to create the server. So I think when I talked about this before, in the proxy pattern, we passed in the server. Well, now we're not going to pass in the server, we're going to pass in a server factory and let the factory decide what type of server to build. Okay, and then of course when somebody asks the client for a request, we'll use the server reference to do something. And we won't really know, is that talking to a Concrete server or a remote server proxy. Now finally, the driver. Okay. In main, we have this reference to a server factory. And then imagine we had this ability to check whether we needed to go and create a remote server or a local one. Okay. So if isRemote is true, then our factory object will point to a remote server factory. Otherwise, a local server is fine, and we'll create a local server factory. Again, both of these implement the server factory interface, so the compiler is totally fine with this. And now when we create a client, we're going to pass in that factory. And again, if we pass in a remote server factory, it's going to create a remote server proxy. If we pass in a local server factory, it's going to create just a concrete server for us. Okay, so now we've kind of localized the check of doing a remote or a local server, and we just pass in the factory to the client, and the client doesn't really need to know anything about whether it's local or remote. Okay, and that's the factory pattern. Again, it's very useful for creating whole families of objects, where the client, we don't really want the client to need to know what type of family of objects it's dealing with. It just knows that different families kind of produce the same objects, and the client asks the factory to create those for us.